Welcome class. Today we're going to be going over graphing techniques and transformations. We're going to try to hit on three different types. We're going to hit on the first being vertical and horizontal shifts. Then we'll talk about compressions and stretches. And then lastly we'll talk about reflections about the x-axis and the y-axis. Okay, so in our first example, I already have the graph here of the parent function x squared, and we see that we're going to shift up 2. So once we're able to graph, the thing that we can do is take every point that we already have graphed and just move it up 2 spots. So I could bring the 0, 0 to 0, 2, bring each point that I have up 2 spots, and you can see that the gap between them is 2. And this red parabola would then be f of x is equal to x squared plus 2. It's showing us a shift vertically up by 2. The next example is a vertical shift down. So again, we're going to use our same parent function, but we're going to take every point that we have and drop it down by 3. So I'll take that down by 3, down by 3, and actually if you just work on one side, you end up seeing being an even function, it's going to mirror on the other side of the y-axis. And so this is going to be the function x squared minus 3, where each point is dropped down by 3. Okay. The next we're going to work on horizontal shifts. Now notice something about this that I want to talk about. We have our parent function, which is just the square root of x, but under the root, we see how this is a minus 2 here. Typically, we want to think of that as, you think of it naturally as moving to the left because it's a minus. But once it's under the root like this, it's going to actually do the opposite. It's going to shift to the right. So it's going to shift to the right too. So every point that I have on this is going to move 2 spots to the right. So that will go to the right, shifting this way. This will shift over 2. This will shift over 2, and this will shift over 2. And then our curve will look something like this. And this will then be f of x is equal to the root of x minus 2, with each point just moving over to the right. This is useful. By knowing your parent function, it makes it quick to graph because you know you're just shifting to the right or to the left or up or down. If you don't know your parent function, you can always use a table and graph these. I'm just trying to show you the quick method of using the parent function to do this. In our next example, we're going to actually move and shift to the left. So we're going to actually shift 3 to the left, and so zooming in on our picture, we're going to move 3 to the left, 3 to the left, and 3 to the left. And we see that this function is going to look basically identical to our parent function. It's just being shifted. So this is f of x is equal to the square root of x plus 3. Again, it's just the opposite sign. So that's our shifts up and down and our shifts to the left and right. Let's go ahead and look at vertical and horizontal shifts done together. So here, this with the x is going to shift us 3 to the right, and the plus 2 is going to shift us up 2. So every point is going to be shifted to the right and then up. So shifted to the right and then up. So I'll take my first point and let's see, 3 to the right, up 2. So 3 to the right, right there, and then up 2. So that is 3 to the right, and then up 2. And then from there, everything is going to be consistent to what we had before. So 3 to the right, up 2. 3 to the right, up 2. 3 to the right, up 2. And 3 to the right, up 2. And so we end up with this function here. And that red function is f of x is equal to the absolute value of x minus 3 and the absolute value is plus 2. Okay, let's look at a vertical stretch. And so what that ends up doing is it's actually going to stretch our function. So all of our values are going to be multiplied by 2. So our 0 won't change. It's going to stay there because 2 times 0 is still going to be 0. 2 times 1 will be 2. And 2 times absolute value of negative 1 will be 2. And then 2 times 2 is going to be 4. And then 4. So this is going to end up looking like this. And this is a stretch, making it steeper. A compression would actually make it wider. So let me do an example of a compression so you guys can see that. But this function here is f of x is equal to twice the absolute value of x. And all I did was take the y values and multiply them by 2. Or I took the x values and multiplied them by 2. Okay. So a compression then is going to take the value and multiply it by half. So again, 0 is going to still stay 0, but half of 1 is going to be 1/2. So it's going to be the same thing over on this side because it's symmetric. Half of 2 is 1. Half of 2 is 1. If we were to go to 4, half of 4 is 2. Half of 4 is 2. And we can see that this is a compression or a flattening out. And the red then ends up being f of x is equal to 1/2 the absolute value of x. Okay? Now we're going to talk about reflections about the x-axis. So if we're reflecting about the x-axis, it's like the x-axis is a mirror. So what ends up happening is we're going to have the exact same points mirrored distance from the x-axis. And then we're ending up with an exact mirror of what we had for our original function. And this ends up being f of x is equal to a negative x squared. You can see the x-axis works like a mirror there for you. Last but not least, a reflection about the y-axis. So again, now the y-axis ends up being our mirror. And so our points are going to be mirrored. That's 4, 2, so it should be negative 4, 2. That's 9, 3, so that should be a negative 9, 3. And if I graph this, it should look identical. And so this is f of x is equal to square root of negative x. And we can see again that the y-axis is like a mirror. Okay. Here is a summary of the graphing techniques. This might be useful to have for our first exam if you want to use it. I think I've left it here long enough for you guys to be able to see. These are the graphing techniques for section 1.6. As always, all the best.